Good afternoon. This is Professor Shannon Gracie from MiraCosta College. Today we'll be covering section 5.4, Polynomials in Several Variables. This section is from Robert Blitzer's Introductory and Intermediate Algebra for College Students textbook. We'll go ahead and get started. Today we'll be evaluating polynomials in several variables. It's very important to understand the vocabulary of polynomials in two variables, and then we'll be doing all the same stuff we were doing with polynomials in one variable. We'll be adding and subtracting and multiplying. So you just need to remember all your rules about multiplying same bases, and all that good stuff, and apply it to polynomials that have more than one variable. Right? So let's go ahead and warm up. We're going to be evaluating the polynomial when x is -2 and y is 3. Pause the movie and check yourself in a moment. Okay, let's see how you did. So we're plugging in for all these x's here. We'll be plugging in -2. And for all the y's, we'll be plugging in 3. So we'll have -2 cubed times 3 plus 2 times -2 times 3 squared plus 5 times -2 minus 2. So here are the x's that we plugged in. And here are the y's. Okay, so this will be equivalent to -8 times 3. And then let's see, we'll have -4 times 9, minus 10 minus 2. This will give us -24 minus 36. And then minus 12. And then combining, let's see, these guys have the same sign, so we'll get a -60. And then decreased by 12 is -72. How'd you do? Awesome. All right. Let's move along. Evaluating a polynomial in several variables. First step, substitute, that's what we did up there. The given value for each variable. Perform the resulting computation using your favorite, the order of operations. Alright, so we did an example for our warm-up of that, and you'll have more practice on the homework. So now, describing polynomials in two variables. In general, a polynomial in two variables, x and y, contains the sum of one or more monomials. In the form, some constant a times x to the n times y to the m. The constant a is the coefficient. The exponents m and n represent whole numbers. The degree of the monomial a times x to the n times y to the m is. So let's think about this. How many variable factors would x have? Well, x to the n means x multiplied to itself n times. So x has n variable factors. And similarly, y has m variable factors. So if you add those, you'll get the degree of the monomial as n plus m. Remember, degree means the number of variable factors. Okay. So let's take a look at this next example. Determine the coefficient of each term, the degree of each term, and the degree of the polynomial. So here we go. So term, we need to also know the coefficient. And we need to know the degree. And the degree of the polynomial, what do we have to do? Good, we have to find the degree of each term, and then the greatest degree is the degree of the polynomial. All right. And there's 1, 2, 3, 4, 5 terms. All right, let's fill in our little chart here. Okay, so first term, 8 times x times y to the 4th. And remember, we could put a 1 up here. X is x to the 1. So what is the coefficient? Good, the coefficient is 8, and the degree is 1 plus 4, which is 5. There are 5 variable factors. Next up, negative 17 x to the 5th, y cubed. Coefficient is negative 17. Degree, good, there's 8 variable factors. 4x squared y to the 1. Coefficient is 4. Degree is 3. Negative 9y cubed. Coefficient, negative 9. Degree is 3. And then 7. Coefficient, 7. Degree, are there any variable factors? No, so the degree is 0. Very good. Alrighty, adding and subtracting polynomials in several variables. Polynomials in several variables are added by, what do you think? Good, combining like terms. So this is just like what you were doing before when you only had x's, right? And you have to be careful. For example, if we look at x squared y and xy squared, are they like terms? What do you think? Are there the same combination of variables? Yes. Are these variables raised to the same powers? No. Do you see? And this x squared y, the x is squared, the y is to the 1 power. X, y squared, the x is to the 1 and the y is squared. These are not like terms, even though the same variables show up in them. Everything has to match exactly. Okay, so let's get started. We can remove the first parentheses. They're not doing anything. There's no number to the left or right that needs to be multiplied. Now over here, we need to distribute that minus sign throughout the parentheses, and that way we can remove that grouping symbol. Minus a minus is plus 4x cubed. Minus a minus is plus x squared y. Minus a plus is minus xy squared. Minus a plus would give us minus 3y cubed. Now let's figure out the like terms. Okay, so here we go. Do you see? Got an x cubed here, and I have 4x cubes here. Those will be like terms. I've got a negative y cubed and negative 3 of those y cubes. Those are like terms, and we already decided that the other ones are not. So in combining like terms, I have, if you still need to commute them, that's fine. I'm going to go ahead and add the like terms or combine the like terms. We'll have 5 of the x cubes. I'm going to keep it as plus x squared y minus xy squared, and now I'll combine the green. So we'll have a negative y cubed minus 3y cubed gives us minus 4 of the y cubes. Okay. And actually, you know what, I don't want to confuse you guys. Instead of doing these in green, I should have done another color since I did something up there in green. So we'll do these guys in yellow. And this is where they were combined, and this is where the x cubes were combined. Okay? Awesome. All right, you guys go ahead and try part B and see how you do. Okay. Here we go. These grouping symbols can be removed because there's a plus sign right here. All right, so we'll have 7x squared y plus 5xy plus 13. Again, nothing being multiplied, no negative we have to distribute. That's why we could remove the grouping symbols. This plus a minus is minus 3x squared y plus 6 times x times y plus 4. Now let's take a look at, like terms. I see a 7x squared y and a negative 3x squared y. The variables, the powers match and the variables match. I also see a 5xy and a 6xy. And I see constants. We've got a positive 13 and a positive 4. So when I combine the blue, I'll get 4 of the x squared y's. When I combine the yellow, I'll get 11 times x times y, and then plus 17. All right. How'd you do? Awesome. Multiplying polynomials in several variables. Okay. The product of monomial forms, or product of monomials, forms the basis of polynomial multiplication, multiplication can be done mentally, by multiplying coefficients, and adding exponents on variables with the same base. Okay, so example 3, multiply. So I'll show more work on part A, and then what we want to do is, kind of as you get more used to this, you'll probably be showing less steps. Okay, so notice that we've got all these are just factors. Everything's being multiplied together. So what I'm going to do is I'm going to commute the things that are similar, right? So 5 times -10, I'll be multiplying the coefficients. Now we have x times x squared. Remember, that's x is x to the 1. And then we have y cubed times y to the 4th. 5 times -10 is -50. And then we'll have x to the 1 plus 2 times y to the 3 plus 4, which will yield a result of -50 x cubed y to the 7th. And we are done. And notice in this particular problem, there was no combining like terms because we didn't use the distributive property at all. Okay? There were just one monomial times another monomial. Okay, so I'll go ahead and do C with you. And there's a couple of ways you can do C. You can, actually, what do you notice about it? Do you see that you've got the same ends, x and 2y to the 4th, x and 2y to the 4th. There's a minus and a plus, right? So my A would be x, and my B would be 2y to the 4th. And I'm doing this one, A minus B times A plus B is equal to A squared minus B squared from our last section. The A's are here, and the B's are here, or you can just, expand it out. So this will be equal to x squared minus 2y to the 4th squared. And this is A, and this is B. And this yields a result of x squared minus 4y to the 4 times 2, which is x squared minus 4y to the 8th. And we are done. So why don't you guys go ahead and give B and D a shot. And you know what? After that, we're going to be all done with our lecture for today. We had 2 short ones. All right, let's see how you did. So this guy here, we will need to distribute negative x to the 7th y squared to each of the terms in the trinomial. So then we'll have plus negative x to the 7th y squared times 7xy, and then minus negative x to the 7th y squared times 4. So now I'm going to put the x to the 7th times x squared next to each other. The y squared is a factor still hanging out. Plus a minus is minus. And then the constant is 7. We have an x to the 7th times x to the 1. A y squared times y to the 1. Minus a minus is plus. And then we will have 4 x to the 7th y squared. Now we don't add the exponents on like the x to the 7th y squared because they're not same bases, so you can't use that rule for them. But here we can. We've got a base of x and x, so this will be negative x to the 7 plus 2 times y squared, minus 7x to the 7 plus 1. Y will be raised to the 2 plus 1. Then plus 4x to the 7th, y squared. So then we will have negative x to the 9th, y squared, minus 7x to the 8th, y cubed, plus 4x to the 7th, y squared, and we're all done. How'd you do? That might have been a wee bit difficult, right? Okay, so this guy, remember, so I won't use the special form on this one. I'm just gonna write it out. So we have x squared minus y times x squared minus y. So this will be, I will hold this guy firm and distribute these two throughout that binomial. And then we will have x squared times x squared minus y minus y times x squared minus y. This will be x squared times x squared minus x squared times y minus y times x squared plus y times y. So this one results in this binomial, and this guy results in this binomial. So now we'll get x to the 2 plus 2. Sorry, that's a little bit hard to read. X to the 2 plus 2 minus x squared y. We can commute this to have minus x squared y and then plus y to the 1 plus 1. So then we'll get x to the 4th minus 2 of the x squared y's. We have like terms, plus y squared. And we are all done. All right, so have a wonderful day and make sure you do your homework.